Okay, the next ones says we have two functions, f and g, and for our functions, they're going to define them as a fraction, f over g. So I'm going to have 2 plus x times negative 4 plus x over the negative 2 minus x. They're just going to make it into a fraction. That's what this part means, right? Now, they want you to find the answer when x is equal to the negative 5 that's in that parenthesis. So in place of all our x's, we're going to put a negative 5. So, in our first set of parentheses, we have 2 plus a negative 5, right? 2 plus negative 5 is?
3.
Negative 3. In our second set of parentheses, we have negative 4 plus negative 5. A negative 4 plus a negative 5 is?
1.
Nope.
20.
Nope.
Oh!
I'm adding negative 4 plus a negative 5.
Plus negative 5. Oh, 9.
Negative 9. Negative 9 over, on the bottom, we have negative 2 minus a negative 5.
Minus negative 5.
Yep, negative 2 minus a negative 5.
So that's 47?
Nope.
Okay, negative 7.
Nope.
No? Okay, negative 2
minus
minus
a negative 5.
a negative 5. 3.
Is 3. Because this would be negative 2, and when you do minus a negative, it changes it to a positive. Negative 2 plus 5 is 3. So now we got to simplify that. On top, we have negative 3 times negative 9. Negative 3 times negative 9 is?
Am I going to put them in parentheses too?
You can.
Times negative 27.
27. So now we have the fraction 27 over 3. 27 over 3. Can we reduce that down?
Yep.
Yep. 27 over 3 is equal to?
9.
9. 9 is my answer. 9 is my answer to the first part. There is still a second part. It says, first of all, find f over g of negative 5, which we just did. Then, find all the values that are not in the domain. So, I have a fraction. If I'm finding the values that are not in the domain, I have to know the bottom of my fraction can't ever be 0 because it gives me a math error. So when I'm doing the second part, I'm going to look at the expression that's in the bottom. The g is in the bottom. I'm going to say the negative 2 minus x cannot be 0. Because I can never have 0 on the bottom. And then I'm just going to solve that. So if I'm going to solve that, what am I going to do? Solve it just like an equal.
You're going to move your x over to the right.
So that makes that
Positive.
a positive x. So negative 2 can't equal x. It's solved because we moved the x because it was negative. So my answer that I'm just going to put in, the negative 2 can't be in the bottom or to have a 0 on the bottom of my fraction. Right? If you did negative 2 minus another negative 2, you get 0. And then I'd have a 0 on the bottom of the fraction, which is what I can't have. So let's look at the next one. Again, tells me I'm going to make this expression into a fraction. I'm going to have the f over the g, so they're in the same order as they are. So the negative 9 plus x, x plus 3, and on the bottom, 9 minus x, and x minus 2. This time it tells us we're going to put what number in for our x's?
Negative 2.
Negative 2. So we're going to put -2 in for each of those x's. And then we're going to find each of our 4 answers since we've got 4 sets of parentheses there. So, starting on the top, -9 plus a -2.
-11.
Yep. The next set of parentheses, -2 plus 3.
1.
1 on the bottom, first set of parentheses. 9 minus a -2.
9 minus, could be 7.
Nope.
9.
9 minus a -2.
9 minus -2, and I still come up with 11.
9 minus a -2.
9 minus -2. Am I entering it wrong? 9 minus -2.
There it is. Right? Minus a negative makes it a positive, so 9 plus 2 is 11.
What was I saying?
7, I thought.
Oh, okay.
Unless I heard
was
you
saying
wrong.
11.
Maybe I heard it wrong. All right. Then the next one. -2 minus a -2. Or -2 minus 2, I guess that just says. -2
4.
minus 2 is going to be
4.
not 4, but
Positive 4.
not positive 4,
Negative 4.
-4.
Why is that?
Because you're adding 2 negatives.
Oh.
When you add, you keep the sign, right?
Oh.
If you owe me $2 and then you owe me 2 more dollars, you're not going to be positive.
Yeah.
You're going to owe me $4. All right, so now we got to do our multiplying. -11 times 1, still -11, right?
Yeah.
Positive 11 times -4,
-44.
-44. Now we got to simplify our fraction. -11 over -44 would be,
Oh, 4. 1/4.
1/4. Yep. 1/4, going to be your answer. Okay? Now this time when we look at what's in our denominator, the g of x, we've got 2 different things there, right? So we're going to have 2 problems to solve. Either the 9 minus x cannot equal 0, or x minus 2 cannot equal 0. So on the first one, what one is the better thing to move?
The 9.
What's the better one? The x is because the x is negative, right? We want the x to be positive, so it's better to move the x. 9 can't equal the x then, right? But on the second one, where the x is positive, it's better to move the number. So if I move the number,
Get 2.
I get 2. So I'm going to have 2 answers, 9 and 2. So which ones are not in the domain? The 9 or the 2? Because I have 2 different ones. Okay?
So I put in both 9 and 2?
Yep. You'll just put them in with a comma. You're
Okay.
going to say 9 comma 2 because I have 2 different answers. Either one of them would make the bottom a 0. Okay. Number 6 then.
Oh shoot, what happened? I thought we were on 6.
Nope.
Okay. I'll just move it down.
Because number 6 is this one.
Because I wrote all the way down.
Ha
Okay.
So, f over g again. So we're going to have 3x squared minus 5 over 2x minus 7. So they made this one a little bit different. It doesn't have the parentheses. It just has our regular equations. We're going to substitute what number in for x?
4.
4. So we're going to put 4 in there and 4 in there. 3 times 4 squared minus 5 and 2 times 4 minus 7, right? So we got to solve that top part. 3 times 4 squared minus 5.
3 times 43.
43, okay, and on the bottom? 1. Ah, 43 over 1? Just 43 then, right? Okay, now we need to find the ones that are not in the domain. So, how do we figure out what's not in the domain?
The 3x,
Which one do we use?
or the 3.
Which one do we use?
Which one are we using?
What do we always use? What part of our fraction can't equal 0? Look at the 2 previous problems. Which ones did we use?
We used 9. And the other one was -2.
Where did those come from?
Right here.
They came from this. Because that was the bottom numbers of our fraction.
Oh.
Here we use this because that was the bottom of our fraction.
Oh, okay, so now we're going to use
So,
2x minus 7.
Yes. So 2x minus 7 can't equal 0, right?
So 2x.
We always use the bottom one because the bottom of our fraction can't equal 0. And so now we need to solve that one. How are we going to solve that one?
We are going to do... Is this going to be 2 answers?
Nope.
No, just one?
This one, we just got one x up there.
Oh, okay. I can remember that one too.
Solve it just like you
So
normally
you're just
would.
going to add your 2x?
Whoops, add your 7,
7.
because you got to move your 7 over, right?
Move 7 over. Cancels out,
So 2x can't equal 7. And then we have to do what with the 2?
Take the x out.
What did we do with the 2? To get the x by itself.
Oh, we're going to move it over to the 7.
How are we going to move it?
Negative.
No, because we're not adding 2. What do we do when the 2 is right in front of the x?
And the 2 is right in front of your x.
Uh-huh.
It's
not-
we divide.
Ah, we divide, exactly. So x cannot be 7 over 2 because we can't simplify that, right?